everyone. Wherever you are around the world, I'd like to convey a warm welcome from all of us on the TDK Ventures team. For those joining us for the first time, welcome. And for those returning after the first two sessions, welcome back. Today, we get to continue our DX Week 2022 journey by exploring a technology that underpins the digital transformation, edge computing. To achieve digital transformation, we need to leverage insights from connected devices to enhance end-user experience and improve decision-making. While this resulted in progress and innovations along with convenience we never thought possible, it always continues to create more data and more processing demand. Enter edge computing. Network can no longer just be powerful, but need to be both powerful and agile. Today, we get to discuss the next generation of edge computing technology with the experts on the forefront of making it happen. And together, maybe we can envision new paths forward. My name is Tina Tosuko Wong, and I am the Investment Director at TDK Ventures, leading the investment in clean tech and advanced material space. Edge computing represents an incredible ecosystem that our team at TDK Ventures has been passionate about exploring. We believe it lies at a crucial intersection of where technology, entrepreneurship, and innovation affect all of humanity for the better. I will be moderating our session today, and similar to the format of Energy Week last year, as well as this week's previous sessions, we designed our panel to be rounded with thought leaders representing academia, industry, entrepreneurs, and the investment community. We are passionate about having diversity in each panel, and we believe this is what will give us an opportunity for real meaningful actions. Speaking of our esteemed panel, I am excited to introduce our panelists and look forward to hearing their thoughts and insights, and perhaps even the contrary views. So for our first panelist, we have Chris Bergie. Chris is the Senior Vice President and General Manager of the Infrastructure line of business at ARM. Chris' organization is responsible for the proliferation of ARM-based solutions throughout the data infrastructure of today and tomorrow, from cloud computing to the network edge. Prior to joining ARM, Chris served as Senior Vice President of Devices Products at Western Digital Corporation and was responsible for product management and product marketing across the company's over $10 billion portfolio of hard drive and flash-based solutions for data center, client, mobile, automotive, and IoT. Previously, Chris was the Vice President of Marketing at Luxtera, a silicon photonics startup that revolutionized data center interconnect after spending over 9 years at Broadcom. Chris holds a bachelor's degree in electrical and computer engineering from Drexel University and an MBA degree from the Smith School of Business at the University of Maryland. Second panelist, we have Pete Warden. Pete was the co-founder of TensorFlow Lite micro open source project at Google and was previously a CTO of Jetpack, a machine learning startup acquired in 2014. He is an author of the TinyML book from O'Reilly and has taught embedded machine learning at Stanford and Harvard. He also has an edX online course. He occasionally blogs at petewarden.com and is on Twitter at petewarden. Third, we have Mike Wildebill. Mike leads Qualcomm's Cloud Edge AI business unit responsible for AI cloud computing, in-cloud edge servers, data center, and enterprise end-to-end solutions. Products include a family of Qualcomm's Cloud Edge AI 100 accelerators and software that accelerate AI/ML inferencing applications. These systems are deployed worldwide in environments ranging from edge to cloud. Mike has extensive experience in high performance and data-intensive computing and has held executive positions at Hewlett-Packard, Data Direct Storage Systems, Sun Microsystems, and the University of California, San Diego. He also served on the board of directors of the Open Scalable File Systems open source project. His vast executive responsibilities have included product management, server and software product development, sales leadership, marketing, advanced development, and academic research. Fourth, we have Dean Brenner. Dean is a leading expert on the allocation of spectrum for wireless technologies and on wireless public policy issues in the United States and around the world. In January 2022, the chairwoman of the Federal Communications Commission, FCC, appointed him to be chairman of the FCC's Technological Advisory Council to lead a new initiative to advise the FCC on 6G, as well as leading ongoing work on spectrum sharing, emerging technologies, and machine learning AI. Mr. Brenner holds a patent on spectrum sharing. He was the co-chair of the U.S. Policy Task Force on the 5G Automotive Association, which is an industry group working on connected car policy. And he was also a member of many wireless industry groups. Dean joined Qualcomm in 2003 after working at a large Washington, D.C. law firm and founding his own law firm. He received his JD from Georgetown University and his AB in Public Policy Studies from Duke University. Next, we are joined by Vinay Riveri. Vinay, CEO of HQ, has over 25 years of experience as a distinguished industry executive and general manager for high-tech corporations in computing, communications, and networking. As an executive, he has navigated the companies through key strategic inflections in areas of cloud computing, machine learning, and 5G. Previously, as a vice president at Qualcomm, Vinay played an integral part in the establishment of its data center server and machine learning technology and drove their advanced mobile software product management. He obtained a Master of Science from Georgia Institute of Technology and a Bachelor of Engineering at City University of New York and holds 12 U.S. patents. And completing our amazing panelist is Elena Ryan. Elena is an investment director for Intel Capital located in the Bay Area. Elena focuses on investments in commerce, IoT, SaaS, enterprise digitization, and deep tech. Elena believes there is tremendous opportunities in disrupting legacy industries by unlocking the insights in their data and creating new customer experience. Elena currently serves as board of directors and observer at Techametrics and Fictive. Prior to Intel Capital, Elena began her career working in engineering, product development, and business development roles across the high-tech industry. She is a Kaufman Fellow and received her MBA from Kellogg School of Management. She has a BS and MS in Electrical and Computer Engineering from University of Toronto and Tufts University. Thank you all so much for making time to join us today. The agenda and format today is pretty much the same as yesterday and will stay consistent throughout the week. We just completed the first section with opening remarks and introductions, and we will now proceed for the next 80 minutes with our panelists to discuss around two key questions on the right side. The most impactful innovation that can be realized in the next 5 years and the most challenging innovation but will disrupt the market in 10 years. Following the discussion will be time for voting poll and some audience Q&A. So audience, please keep your cell phone nearby. We will need that for voting. So let's get into it. Panelists, please find the link in the chat on the right-hand side of your screen. And please click on that link to submit your answer on what you think is the most impactful innovation that can be realized in the next 5 years in edge computing. And we will then use that answer to begin our discussion. right, I started to see the answer popping up. Converging compute and connectivity for the immersive edge, AR, VR, metaverse. Okay. More sophisticated processing, including AI on edge device. Connecting the unconnected edge, distributed edge computing, digital twins. Oh, okay. Very interesting. Everyday devices will have ML capabilities like voice and gesture interface running locally. So I think I start to see the trends that we're going to see as from the device standpoint and also the innovations on the computing and connectivities. And then the fifth one, 5G is currently in an early stage, but over the next 5 years, 5G will be mature and be enhanced substantially. And this enhancement will enable much greater support from 5G for both edge computing and the cloud. So we have 5 response. Do we have one more? Do we have everything covered? Okay, so I'm gonna wait 5 more seconds to see if we have one more. All right, so I think we can maybe get into it. So Elena, ladies first, what do you think is the most impactful innovation realizable in 5 years?
Thanks, Tina. In today's environment, right, there's the problems that I'm seeing is monolithic software, specialized hardware, and proprietary technology limit the flexibility. We have the unprecedented number of edge nodes and location, unique legacy, edge hardware software requirement, mission critical, physical and security, enterprise need. And that bring us with a lot of transformational opportunities. There's opportunity to connect the unconnected, connect everything obtained and normalize data, drive access through standards, consortiums, adopt sort of IT-like system management system utilizing factory operating systems, cybersecurity, software upgradability, open API, application virtualization, etc. And that with all those data, so apparently the 51% of all data, 90 gigabyte, will be created on IoT device by 2025. And how to utilize analytic machine learning, predictive maintenance, vision system, digital twin to improve that efficiency, effectiveness, responsiveness. There's a lot of transformational opportunity in this edge compute environment.
That is so awesome. That's very interesting. And maybe, Pete, you touched upon a lot of these edge devices. What do you see we are evolving in the next 5 years?
So really, one of the things I really want to have for myself is a light switch that I can just look at and say on and off, because I really feel like we've got ourselves tied in knots with a lot of the sort of centralized hub voice interfaces. And I feel like there were so many improvements in the experience that we can actually offer through doing the processing on the edge, and also improvements in privacy. If you can actually keep things like voice and image data completely local to the device, then you really don't have to worry about it leaking or people getting hold of your recordings. So I see a really interesting few years where we're now able to, on the technical side, implement these capabilities. We just kind of have to get them out there.
Very interesting. Can you double click a little bit? We want more smart devices, but at the same time, we are worried about the privacy and things like that. Do you see that the role that the hardware can play or the software can play in ensuring that we have the right information at the device and not leaking it out?
Yeah, I mean, what's been really interesting is that there's been this explosion in the amount of compute that's available on the edge. And what it seems like is that really the hardware people have been ready with a whole bunch of computing power and sort of looking for ways to use it. And that's what I think is really interesting about the machine learning side is, we now are able to run voice recognition and person detection and gesture recognition locally on, pretty cheap devices, even things like the Raspberry Pi Pico, which is 70 cents in bulk. You can actually run some pretty decent, person detection and computer vision algorithms on that. So that just feels like it's this wave that's starting to build because all the factors to help support it have kind of come together.
That's amazing. And Mike, you've worked in many use cases. Do you agree? And what do you think? How do you think the industry is going to evolve in next 5 years?
Yeah, I think Pete's example is a really good one. Technology will push and application or need will pull. And these two things work together to really drive and steer innovation. Fundamental and why we're all here talking about edge in general is that we live under this tyranny of physics, that distance limits latency and data movement consumes energy, and we're forced by just the laws of physics to do more and more computation at the edge, and there's no escaping that. Back when I was in grade school, I was taught that the speed of light will travel about that far in a nanosecond. And last time I checked, that's not changed. The speed of light is not increasing with Moore's law, for example. And so we do have some very fundamental boundaries that we work within that are forcing more computing at the edge. Today, using autonomous delivery robots as an example, we have robotics today that can autonomously identify and classify objects. They can navigate a path, even in public, on public roadways, avoiding collisions, identifying and determining the most efficient route, and on and on. And these systems today may be running on hundreds of teraops, 8-bit integer operations, approaching petaops in terms of performance. But looking out 5 years, we see that the need for more computation and more efficient computation is only growing near exponentially. In the future, that autonomous robot is really, to be effective, is going to have a better understanding of the world around it, and to better predict the behavior of those things around it. And so let me use one example. As you're driving down the road and you see a pedestrian standing on the sidewalk near the road, it's very common to kind of pay attention to that and be very concerned that they might step in front of your car. And so you're on alert. But if that same person is standing next to a bus stop, then the context is different, and you're probably not as nervous about them stepping out because they're waiting for a bus. And if they're sitting on the bench waiting for a bus, then you're not even really thinking at all about the likelihood or the probability of them jumping out in front of your vehicle. And the same is true if somebody is walking a dog, or is walking with assistance of a cane or something. This is context, and as in the example of the autonomous robot, delivery robot, in order to more effectively integrate into the world around it, these devices at the edge have to have much more processing power in order to establish much greater context. Pete's example was exactly right. An example of this would be, why doesn't your light turn on when you look at the light switch instead of you having to get up off the couch and go and flip it? And that's just a perfect, clear example of context driven behavior, which really comes with more computation and greater connectivity. And so I'll finish with performance, because this is so important to this panel, I think, as well. There's a virtuous cycle. Performance enables new applications. New applications demand more requirements and therefore drive more innovation. In my career alone, I started my career developing on supercomputers, trying to get a gigaflop, 64-bit operation, a gigaflop performance on a supercomputer. And not soon after that, we were deploying teraflop computers and petaflop computers. And now in the next year, we're going to see exaflop computers begin to be rolled out by large institutions and government agencies. This is 100 million X increase in performance that I've seen just in my career. And that rate of growth and the need for computation at the edge is growing even faster. And, when just 2 years ago, I was seeing a lot of 1 tera ops, 1 trillion operations per second capabilities in mobile devices. You can see 30 tera ops in mobile devices today. We're seeing 400 tera ops in a single system on a chip SoC such as this. Can you imagine 400 trillion operations per second out of something so compact? And that we're seeing the ability to do multiple petaops in just a 2U enterprise rack. And the insatiable need and demand for performance is only increasing, it's only accelerating. And I'll finish with, it's the performance, it's the connectivity, including latency and bandwidth to the edge, and it's the power efficiency. And all of these things, the innovations in these areas are just going at light speed, pardon the pun. And we're going to see the applications, whether it be look at my light switch or expect my autonomous vehicle to be more intelligent about the world around it. We're only going to see this trend continuing to accelerate exponentially.
Wow, I think I heard a lot of keywords. More AI, better computation, better connectivities. Dean, could you chime in on this? Do you agree that's what is going to be needed in the next 5 years?
Hi. So first of all, thanks very much to TDK Ventures for inviting me to be on this panel. So from my perspective, I'm going to say that COVID has changed everything about this panel. So pre-COVID, I was working on the very early days of 5G, and the most common question that I would get from people outside of the industry, people in policymakers and governments in the United States or around the world, and just everyday friends and neighbors, was 5G. Like, why do I need that? What's that going to do for me? I mean, I already have a phone. I already have pretty good connectivity. And I think COVID, unfortunately, it's such a terrible virus. It's killed so many people. It's changed so many lives for the worse. But one thing for sure it's taught all of us is everyone wants, needs, and must have the best possible connectivity. If I just go down my street here in Washington, D.C., and I say, hey, there's this new connectivity, it's much better, I'm getting much better uploads and downloads. Hey, neighbor, do you want it? Everyone's going to say, I want it right now. I got to have it right now. So from my perspective, I believe that has changed everything. We don't have to worry for this panel about whether people want edge computing. If edge computing enables faster, better capabilities, everyone's going to want it, and the same really for the cloud. So I do agree with the things that Mike was talking about, but I think the main thing is when we invented 1G, 2G, 3G, and 4G, when those were on the whiteboard, we just invented technology, tried to make wireless connectivity better, and we thought, we're not sure how it's going to be used. We'll just have to see how the market evolves. With 5G, it was a little bit different. There were use cases specific to 5G and from its inception, and there still are. And of course, an early part of the vision for 5G was to enable better edge computing and specifically mobile edge computing. And I think over the next 5 years, as 5G matures, as it enhances through the next several versions, I think edge computing is going to just go through the roof as an important application, just because it works better. It enables better connectivity. That's why we're seeing just on Monday, Verizon making a major investment in mobile edge computing. We see all these partnerships between network operators and technology developers. So I really see that COVID is having dramatically changed the landscape.
Thank you, Dean. And Chris, from your vantage point of looking at the cloud, looking at the edge network, do you agree that's where we're heading in 5 years?
Yeah, and evidently I failed the listen to the instructions on how to upload your comments. So what I had actually proposed was a secure software-defined dynamic edge, and I think I'm really reiterating a lot of what the other panelists have said, except for maybe added the concept of secure. But let's just go back to that. I think Dean just made one of the comments I was going to make is, we moved to SD-WAN, or basically software-defined networking, and kind of the core network. It has been pretty prevalent or considerably rolled out over the last 5+ years. And I think that the COVID dynamic and the way that traffic patterns just overnight just changed relative to the types of bandwidth people wanted at home, and the way that people were working with all of these video calls and all that kind of stuff. And of course, it was not flawless, but it was darn close to flawless. And that was, I think, really due to, again, this software-defined dynamic edge. And really, if you look at core networks, that was really kind of the first start. You now see a lot of those technologies moving into 5G, whether that be virtual RAN and other parts of the networking stack, and being able to make that very portable. And so we see that as, really, I think the early cases of what you're going to see. The last thing I was just going to add was, again, I think the importance of security. And again, we talk about security in a lot of different ways. But one of the things about, if you think about cloud computing, is, if those of you on the call who kind of work with some of the larger cloud operators, it is about the most impossible thing on earth to actually get into one of these data centers. They are locked down. They literally destroy computing materials in the facility because they're worried about customer data getting out on old hard drives or old motherboards or whatever. And so that's possible when you have kind of these mega data centers. But when you go to the edge and you have things in colos, or you have things in racks, and you have who knows where you're putting stuff, right? Kind of all over the place. Physical security is no longer assured, and so you really need to think about how you're going to secure that computing. And there's a lot of really important technologies that have been developed by the industry to add. So that's just the only thing I would add as a little additional flavor to what the other panelists have said.
Interesting that you brought up the security, right? Is this something that we can address by the software or the hardware? I wonder if maybe Pete want to chime in. How do we start enhancing more security on the edge device and the edge network?
So, I mean, I can jump in on that. I mean, one of the things I love to do is anything that we can do completely on the edge with no network connectivity. Like, let's see if we can actually do that. Because, there's a lot of focus on securing data as it travels across the network. And, that's great. But what we find is a lot of consumers actually don't even trust the big cloud companies that they're sending data to. So cloud companies have traditionally been very focused on external vets. But when it comes to privacy, a lot of end users are like, yeah, I want to use this device, but I don't really want to send this data, my speech data or my, video to Google or Apple or Amazon. So that's where I think that there's a big opportunity to do as much as possible locally, and then not even have to think about what happens once it gets into the data center. Because kind of like that, I think somebody said about destroying stuff within the data center, personal information is almost like toxic waste now for a lot of the companies, because they really have such a liability if it escapes, that they have to put so much work into making sure it doesn't. in a lot of ways, it actually makes life a lot easier if you can just send kind of actionable information versus the raw kind of data, which is often more sensitive.
But are we there yet in terms of doing most of the things just on the device without connecting to the edge of the network or the cloud center? Do you have any sort of the best practice? What do you want to do on the device, and maybe what do you want to do on the network?
Well, I think one example is, this is a Pixel phone, and Google has for a couple of years now actually had on-device speech recognition, which is as good as the server-side speech recognition. So the technology is there; it's just not evenly distributed to kind of run voice interfaces locally. um, I feel like the technology is starting to emerge for a lot of these, you know, things around processing audio and image data. It just it it requires a bunch of development.
Very well said. So I'm going to turn to Vinay from the vantage point of the entrepreneurs. How do you see we are going in 5 years, and what do you plan to work on to address all these interesting, the device, the network, the connectivities?
Yeah. So maybe start with what's happening today, what's going to happen in 5 years, and what's going to happen in 10 years. Elon buys Twitter today, Elon buys Silicon Valley in 5 years, and Elon buys a country in 10 years. Start with that, and then the rest will fall in place. uh, but yes, on a serious note, so I I think the other panelists put it well. It's edge compute and connectivity, they kind of go hand in hand. You can't talk about one without the other. And so I certainly think that those are all the right vectors. Maybe what I'll do is I'll kind of spend some time on how they come together and some of the parameters and applications and prerequisites to make those happen. We're I don't know, we're in the Web 3.0 type of a world today, meaning it's secure, it's more sophisticated, but all of this really comes down to the experience that people want to see, the immersive experience to the edge. That comes in many shapes and flavors, but a lot of it is going to be visual. And that requires super low latency, extremely high amount of bandwidth being delivered to the end application. To do these things, we'll just kind of use this high-level term called edge compute, meaning that you really have to bring the processing or computation to where the data is being generated or where the end application itself is, whether it's AR, VR based on glasses or some robot that's in a factory or something of that nature. So, but to deliver this edge compute, latency is an important thing to control. And in these larger cloud companies, where they tend to be centralized, the compute as the compute will have to get closer to the data, meaning edge. To do that, um, some aspects of connectivity have to change, particularly around latency and reliability of these things. And 5G certainly is a key technology in that. But also the amount of bandwidth associated with all this, right? You do have to have very high bandwidth links, and they tend to be cheaper because they're at the edge, not necessarily going, thousands of miles out. But that's one piece of the puzzle. Particularly on the compute, the traditional compute, let's say, what are they and how is that going to work? Um, take as an example video. We're visual beings, so video is a very important thing, even not just for humans, just for even robots. There, as you see, computer vision is how most of these intelligent decisions are made at the edge. Whatever you want to call them, sensing, but it is based on some form of vision most of the time. And to do those types of applications, machine learning will play a big role, particularly like edge inferences, to do computer vision applications. So that's essentially kind of putting compute at the edge device itself, or one hop away. Maybe it's an access point, maybe it's a server that's close to it. Another is an interesting thing is, particularly if you're doing AR, VR, whether it's gaming or something else, there's graphical computation that has to happen. And those are extremely power hungry and computation hungry type of applications. And it's really difficult to do them right on a headset or even a phone. You can do graphical computation today, sophisticated stuff on a phone, but to be able to do them to the tune of like a really immersive game is actually pretty difficult. But instead, maybe there's some remote rendering that could be done, and then push that to the edge device itself. And these are newer concepts. To do that, you have to have a link that's really, really fast, because you want to be able to move your head, and then the scene changes, and the graphics get rendered, and it's presented, all of that happening within a millisecond. And that's pretty complicated and pretty difficult to do today. So I'd say that these are the type of things that have to happen, where you compress video, render video or graphics remotely, but present them locally. And location plays a role in all this as well, meaning precise calculation of where you are, because if you move physically, that it has to be known that you moved, and you moved left or right, or you like went in a circle. So these things have to also, and they're all computationally heavy. So I'd say that these are the type of challenges the industry has, and a lot of it will have to get done in silicon, because you want this to be power efficient, you want this to be fast, and you want this to be in a form factor that is small. So I see a lot of really interesting and innovations coming up in the next 5 years to accomplish these types of applications. So that's kind of my answer, but the more fun answer is what Elon's going to do next.
Thank you so much. Elena, do you agree with Vinay, or do you agree that Elon's going to spice everything up?
Elon will have a very, from sort of space rocket coming down to Earth kind of approach. And while we're here, right, trying to make everyday works, we're looking at, especially from venture investors' perspective, looking to really entrepreneurs to invest. We're very synthesized from looking at everyday's implementation. A lot of challenge like end customer customization, make some kind of industrial IoT edge intelligent scalability not as easy today to proliferate. There's still a intense cost pressure on the industrial applications, long contract sales cycles. There's a challenge of legacy OT system difficult to change and influence. But given that said, I'm seeing entrepreneurs in orchestration side, in just device sort of virtualization side. Every day, I'm seeing a lot of CEOs really face hard on to the challenge problems, making scalability happen. I'm starting seeing some of the taking scalability in end customer applications more and more toward edge compute with the panel's discussion, right? With overcoming the latency bandwidth, real-time deterministic, and make that deployment happen.
Very interesting, and maybe similar question along the line of metaverse, right? I think we had a panel on the metaverse on Monday, and I would like to ask, it seems like a lot of big tech company that it's going to be the next big thing, but it seems like there's still a lot of challenges. Do you see for edge computing that the demand that will help edge proliferate will be driven mainly by the metaverse, or is there any other applications that's really just going to drive all these convergence of computing connectivity on the edge?
I can comment on that. This is Mike, and maybe tying into the previous discussion around Elon. Elon Musk has really sparked a lot of innovation and imagination around many of the things he's done. Looking at Tesla as an example, and identifying a grand challenge of autonomous driving as something that he's put tremendous resources behind and is making a lot of progress toward. I think in the spirit of this panel, I think that those are excellent examples of application pull that then have an impact on the speed of innovation to support that grand challenge requirement. I think as we look out, though, to the next 5 years and beyond, there's an additional element there, which is pulling the industry together in those directions. Industry standards or interoperability, or the ability for multiple technology innovators to mix and match their technologies together to yield or to provide an end product that's consumed at the end by the consumer. And I think that a really difficult challenge between the initial vision and the initial demonstration of something is usually vertically integrated, and then moving that towards something that an entire industry can go after and make real compelling global scale impact, I think takes a lot of energy and takes a lot of cooperation with industry. And I think that also plays true with metaverse as well, and that our imaginations are being sparked by some things that we're seeing, similar to the autonomous driving example. We're seeing new possibilities. The art of the possible just changed with Meta and the metaverse. And it's going to be interesting to drive those use cases, to drive those technologies, but also to make sure that those are not just vertically integrated point solutions, but rather are technologies that industry as a whole come together and drive a very impactful, broad set of deployment of that technology, and not be too focused on just one use case. And so I would open the aperture of the discussion to include not just doing the proof or the single demonstration, but the hard work of making that something that industry and society as a whole can drive forward.
Excellent. So I think this is a good segue to the second question for today's session, to consider a longer time horizon. So panelists, please once again see the chat on the right-hand side of your screen and click on the link to answer. What do you think is the most challenging innovation but will disrupt the market in 10 years for edge computing? Smart dust, what is that? That's interesting. Human compute interface wearables, brainwave, or neural link driven. Okay. Ubiquitous, autonomous defined edge. Computing at the edge will become more dramatic. True autonomy. In 10 years, 6G will have been planned, designed, and deployed, and it is bound to disrupt in a major way. All right, since I think we are quite interested in what's happening in 10 years, so I'm going to start off with maybe the 6G. So Dean, is that your answer?
Yeah, that was my answer. And, it has to be taken in context with my prior answer. 5G has still, a very long runway. 5G standards are, continuing to be enhanced. But usually a G has had a lifespan of about 10 years. So the first 5G deployments occurred in about 2019, 2020. So in about, if that timeline were to hold, over the next 10 years, 6G will be conceptualized, planned, designed, and it will have been it will be in an early stage of deployment. Now, of course, it's at a very early stage right now to talk about what 6G will be like, and many different companies, many different government policymakers are just starting to work on it. But we know a couple things. So first of all, we know every single country in the world is going to want to be the leader in 6G. We had kind of a race like that to 5G, although it started towards the end of the beginning of 5G. But 6G, even now, kind of the 6G race is on. That's one thing we know. A second thing we know is for each G, there's been, a more than 10x improvement in capacity. Basically, in order for the billions of dollars of investment to occur in a new G, it's got to be a lot better than the prior G. So we know 6G is going to have to be disruptive in all kinds of ways in providing the kind of connectivity that we can only dream about today. We know that. And then the other thing that we know is so many new players, so many new industries are coming in to 5G, the automotive industry, industrial IoT, IoT itself. Those are all relatively new players to 5G. And those companies that are in those various verticals, and the metaverse is another one, edge computing in general is another big one. None of them are going to go take a vacation from 6G. They're all already thinking about 6G. So the way one of these new Gs gets planned, there's the individual company on the private sector. You have individual companies, you have groups of companies through standards bodies, and then you have some sort of universal adoption that takes giant capital investment, that takes a lot of time, that takes a lot of bets by venture capital concerns like TDK Ventures, Intel Capital, et cetera. That's on the private sector side. And on the public sector side, we have national regulators like the FCC, like Ofcom, like BRR in China, for example. We have regional groups of regulators. Not CTEL is the group of regional regulators in the Americas. We have APT in Asia. We have the RSPG in Europe, and then we have the ITU and kind of global attempts at regulation. So all of those players have to work together in parallel in various activities for 6G to come together. But we know there won't be any 6G that isn't disruptive. It will have to be disruptive.
Very nice. So I want to turn to Vinay. So we heard from the chair of Tech Advisory Committee at FCC what we have to provide for the 6G to happen. So from the vantage point of the entrepreneur, do you have a laundry list of what you want to see being implemented for 6G? And maybe what do you think will be the most disruptive in 10 years?
I'm still wrapping my head around 5G, so I'm not so sure if I can say much about 6G yet. Us being a 5G company, I kind of see these technology transformations like in two phases. One is a technology development phase, and then the next services that kind of get built on top of it. Just kind of looking back, cloud is, as you know it today, started out as just first somebody has to develop that thing, deploy it, whether it's AWS, Google, whatever, and then services get built on it like Uber and these other things that came as a application of that cloud. So in the same way, we are in the technology development phase of 5G, right? Even the deployment of a network is still sort of part of that. And then services have to get built on top. That is when it's really utilized. And we are not quite there on the services built on top of 5G. I'd say that probably will happen. Next 5 years is going to be the technology development, and then post that will be the services that get built on top of that. So 5 to 10 years, I would say you're going to see hopefully more of the applications of 5G itself. Now, when it comes to 6G, between now and then, you sort of compile requirements and play with different fundamental technologies, whether it's terahertz processing, things like you hear things like human interface to a computer rather than it just being us typing stuff. It's might be through an automatic interface through your like neural link. I love Elon, so he's got his neural link thing going. Uh, uh, but this to me is still sort of a playground from now to the next decade, and then comes the actual technology development, so that it becomes something more than R&D, rather research project. So 6G may be an enabling technology for such things like true wearables, not just a watch, but maybe it's a thing that actually delivers medicine on its own into your system. Today, people do talk about, can I communicate with a computer without actually speaking to it, just by thinking it? Quadriplegics, so those types of people can really benefit in the beginning, but over time, just we're lazy people, right? Human beings. I'd love to just sit there and let the computer do the work without actually going through it. Just this panel, maybe I could just sit here and then it will communicate for me. But those are services, I would say, that are 10 plus years away, maybe 15 years away. But I will close out by saying one thing. I actually just hate to guess what the future will be, because I don't think most people are just get that wrong. Because I don't think we could really connect the dots, as Steve Jobs once said. Connecting the dots is always a rear view mirror thing, and just know that what you're doing today will figure itself out, and things will work out. But really, these are all just guesses, and hopefully a few of them will hit.
Excellent. I really like to think about that wearable for the next use case in 10 years. But one thing that caught my eyes is smart dust application. What is that? Who can chime in here?
So I put that down, so maybe I can start. One of the trends I see is that compute keeps getting smaller and smaller and smaller, and more energy efficient. So if you start to think about continuing that trend over the next 10 years, what I'm hoping we end up with are devices that are, smaller than a grain of rice, getting down to that kind of like smart dust, that actually include enough battery power to run things like ML computing, to maybe, things like having tiny devices scattered in a field able to recognize crop pests and actually, help better apply chemicals and help better do more ecologically friendly, pest control, or, mixing devices into concrete when a bridge is built, so that you actually have the ability to monitor the progress of this stuff. We're having devices that are peel and stick sensors, for example, to kind of spot a water leak using vision technology, but they're so cheap and easy to install that you just kind of, slap them everywhere, and they just wake up when, 5 years in, when something bad happens. And yeah, I just think that if you think that far ahead, the sort of trends for there's more and more compute in smaller and smaller packages. I don't even know exactly what we're going to do with these things, but from an engineering point of view, it seems pretty clear that that's the direction we're headed in.
That is so futuristic. Elena, is that investable idea?
I should repeat your idea of smart dust. It's very inspirational already. Quite excited. Think about 10 years out with that crystal ball of smart dust, right? Compute is getting more power efficient, lower cost, ubiquitous, and everything. And the way I see how that driving automation and how I'm looking for my investment in the venture space is that there's a different level of automation as we get into the smart dust level. Eventually, I'll call 5 level of automation. Anywhere from level 1 is probably a single automated operation. Machines do not have the capability to sense and adapt to change in the environment. Moving on with more powerful machine learning algorithm and hardware. So level 2 is partial automation. Machine can sense the environment. They can make minor adjustment. Level 3 is more conditional automation. Machine control and monitor all the environment, but still need humans' attention and intervention. While we're closing to smart desk piece idea, we're going to see level 4 and level 5. Level 4 will be more high automation with full autonomous in a defined area or certain solution. Or once we get to level 5, then there's complete autonomy, full autonomous in all situations. That's linking our mind to use our neuroscience to control the light switch, control the temperature, really become complete automation. So I thought that was a really tying back to Pete's smart desk ideas. That's going to power the next 10 years of autonomous development.
Very insightful. So the smaller edge device is going to get smarter and smarter. Does that mean that that's going to eliminate the cloud computing? What do you think is going on, Chris, in 10 years?
Well, I also focused on kind of true autonomy because I think as Ilana did a nice job of just explaining what is autonomy, right? And since Alon's the thread here, as a Tesla owner who paid for the self-driving upgrade, I can tell you that it's nice, it's convenient, but it's very far from self-driving, right? And even in the best of conditions, and I think that's the challenge, right? I think Mike said it well, right? It's easy to build a prototype, right? In optimal situations, but it's about all those corner cases, and I actually even think back to video conferencing and things like that. I mean, I remember trying to do, us demonstrating that we could do it on 56K modems, right? And of course you could use it in optimal situation, but you couldn't use it in the way we do today. But obviously now we have gigabits of bandwidth to our homes and just a totally different kind of network build out and in computing capability. So I think that's really what in a lot of ways, edge computing has kind of disappointed, I would say, because it's only really been some verticals that had super high bandwidth or super specific computing needs. And it's just because it's too expensive and the compute is not ubiquitous enough, right? And I think as the smart dust example or the light switch example, I mean, the amount of computing that we're putting all over the place, that computing just rises all boats. And so I think that's what we're going to see. But I mean, again, I think the promise of autonomy is still very, very far away. I mean, there are examples of again, very controlled environments, whether that be, lights out factories or, but it's very far from, I would say people being comfortable with, airplanes not having pilots and, drone delivery all over, come flying down your street and, from multiple vendors and stuff like that. I mean, those things are going to happen, but a prototype to reality is probably something like 20 years. And so I do think that kind of full autonomy and what does that mean? There's just so much energy, money, intelligence that's being put into it. We're going to see it, but it's, unfortunately the hype gets way ahead of where the reality is. But I think the idea of autonomy, and then of course, this kind of fits back to your metaverse question, is autonomy or things like virtual worlds just drive a different level of computing and different relative latency requirements. And so those things also really drive edge computing because, but again, you need to assume you have it under a pretty high percentage of use cases to really be able to depend on it. Otherwise, you have to put all of that kind of in the device, as Pete was highlighting.
Very nice, very nice. And Mike, from your point of view, how do we enable all these and accelerate these so that we can see some substantial progress in 10 years?
Yeah, this is an excellent discussion. I'm really enjoying it. So, I do believe the future holds for more nomadic computing happening not only on device, but on devices nearby. And this will be enabled by advances in connectivity. The requirements needed for more ubiquitous computing will help shape standards for next gen and next generation connectivity. So in the past, and by the way, on Pete's comment, the sensors in concrete, really good example. I don't know if the future is going to hold smart marbles or smart breadcrumbs or smart dust. I don't quite know exactly how small smart devices will become, but the point is that there's going to be lots of them. There's no doubt. And using the sensors in concrete as an example, I think it's an excellent example. As in the future, as that engineer goes to design that sensor, are they going to design it for the standard operation environment of the bridge that is being made out of concrete? Or are they going to spec all of the performance, the storage, the connectivity, the bandwidth based on a very rare event like an earthquake? And I think that the future of smart dust, smart crumbs, however big these discrete things are, in order for us to really make them ubiquitous, we need to be able to design them for a standard operation environment, not for the peak requirement, not for the earthquake that happens once every 30 years, but for the standard operation that happens every week or every day. And so therefore we need our devices to be able to share resources or to utilize resources of smart devices around them. So in the past, the academic community put a lot of energy in many years back around grid computing, technologies like Globus, Condor, Legion, SETI at home. Remember the search for extraterrestrial life, a screensaver that runs on your PC that's actually doing number crunching when you're not using your PC. These are all forms of grid computing, of sharing resources when a resource is underutilized. And it was good academic research. I think a lot of good stuff came out of it, but it was more of a stunt or a prototype, and it required very close alignment of the administrative domains. You needed administrators of all these systems to agree to what port are you using, when do you do it, what are the security protocols and all that. And in true ubiquitous computing, we need, Chris's comment about secure dynamic edge is spot on. And that is that we need this ability for ubiquitous shared computing in a way that's secure and it's dynamic across the edge. And so I think that's exactly the direction we're going to see in the next 10 to 15 years. It's going to enable a lot more deployment of sensors and devices, because now we can think about deploying a device that is designed and has a cost point for its expected operational environment, not for the peak once every 30 years event. And therefore I think we'll be able to see a lot more ubiquitous deployment of sensors. And so for an example, the power grid, long ago, it would have been inconceivable for a city to think that they're going to connect their power grid to a nearby city, so that if the nearby city is low on electricity, they'll grab electricity from the first city. That was an unheard of or an inconceivable concept. And yet today, when you plug in your toaster oven, I don't think anyone can tell you where that electricity was sourced, because it is now in a grid environment, and all of the benefits that come from the electrical power grid. I think that we're going to see similar standards, protocols, and technologies that allow for that type of a vision to occur in the connectivity space, not just in the electricity space. And if you look at the power grid and what it has brought in terms of cost reduction, in terms of efficiency, in terms of reliability and stability, it's been phenomenal. And I think 15 years out, we're going to see very similar activity occurring at the edge. And so in the future, a nearby device might ask your smartwatch or your smartphone for a little help. And I believe that there will be standards, protocols, and capabilities that allow for that to happen in a way that's not disruptive and is kind of the common good of the edge ecosystem as a whole. There's a lot of work that needs to be done, to get there, but the prototypes have been done. Chris's example of, I remember also big ideas trying to demonstrate on a modem, a 56K modem, And sometimes these prototypes that we see today, like with grid computing, are a little bit early, but they're showing the promise, I think, of what is possible with greater connectivity and connectivity between devices.
Very interesting to think about share resources, right? Do you think like in 10 years, humans gonna be generous, like my neighbor's gonna let me use their device to do the compute? Who's gonna make that happen? Anyone want to chime in?
I can start. I'd love to hear other panelists, but for example, think about the benefit to society of automobiles communicating with each other electronically. An automobile, if it's going to start braking, it can communicate to cars around it what it's, so they can predict what it's going to do. Hey, I'm in a hard stop. And we need not, the future need not be the scenario where the car behind it has to wait to see the brake light come on and then has to wait a few microseconds to kind of get a feel for, is this a slow stop or a hard stop, and then to react. And I do think that this cooperative communications is something that we will see, and that there will have to be the controls and that are around it, just like on Apple devices, we all share files and pictures back and forth. And of course, there's protocols and approvals and authorizations that have to take place before you enable some types of sharing of connectivity. But you can see the ability to go up to a stranger and in a very quick amount of time transact what's needed so you can share a very large file with them or a photograph. We're seeing that today. And I think that that's only going to continue. I'd love to hear other panelists if they have opinions on this.
Well, this could be an interesting one for Dean, but I mean, I think one of the interesting experiences is the Helium Project, for people that are aware of that, where people are actually sharing connectivity and crowdsourcing connectivity and using basically blockchain crypto as, kind of like you said, why am I going to do this? Well, you can actually make money. And so it's an interesting project from a connectivity point of view, attempting that. I think also, we always think about, well, are we computing in kind of endpoints? I mean, I think I talked about portability. I mean, if you look at the essence of cloud computing, right, the essence of cloud computing is portability, and that portability can happen in a vertical stack. So everything from on-prem to an edge location to the mega data center. And it also happens in the data center, right? Because that was really the birth of cloud computing, was a lot of scale out, which means that you could take workloads and just blow them up across, a wide array of processors. So that portability is clearly what a lot of cloud native software is being written, and cloud native software is no longer just for the cloud. We're doing a lot of things at ARM around cloud native in devices, and that portability and security frameworks, all the way down to the light switch that Peter is imagining.
Yeah, I'd like to add, I think what Mike's talking about is, very viable, and it's actually not that new of an idea. It's been talked about in the context of, for example, open access, where, I have I'm providing connectivity to my neighbors, and in exchange for in a bilateral kind of deal, they're going to open up their access point to me. And maybe we each get, the equivalent of frequent flyer miles. We get some kind of frequent stayer points from our network operator in exchange for our doing that. That's one kind of business model for it. And then, with the connected cars is a great example. If my car has connectivity, but no one else's does, like, that doesn't really do anything for me. But, there's this unbelievably tremendous network effect where if we all have it, the value to each of us just goes through the roof. It's funny, the cable TV industry solved this with, the cable bundle, where, you couldn't just buy the cable channel that you liked on an a la carte basis. No, my option is to take the whole cable bundle. It includes channels that I watch all the time and channels that I never watch. So then the streaming platform came along to kind of deposition that, right? And oh no, you can do streaming, but you'll just, basically you can just stream what you want when you want it. And now we see with what's happened today with Netflix, maybe the business model is kind of going back towards more of a bundle with tiers. So I think, great business people can absolutely enable the vision for what Mike's talking about, without a doubt.
Very nice, very nice. So I think this is probably a good segue. Thank you so much, panelists, for sharing your thought and vision for the answers about the futures. And I want to take this time to let the audience chime in as well. So I'm gonna open up the floor for the audience feedback. So everyone's watching, please grab your cell phone. This is the opportunity for you to give us some feedback. So first of all, you will see the QR code come up on the screen, and you should be able to find the link after you scan the QR code on the right-hand side. And that will be the polling page. First, we will ask what industry sector you're joining from. And then it will follow to a new page that asks you to vote on the panelist's answer to question 1 that you found the most interesting. All right, I start seeing the response. So, okay, that's changing very quickly. We have the majority of the audience right now coming from the industry. We still have 40 seconds to go. So, oh, I see government nonprofit joining as well. That's wonderful. And startups and investors. So I think we are quite well represented with a lot of industry representation. That is so awesome. So if you have friends in the government, in the investor community or startup community, please grab them for our session tomorrow and Friday. We want to see every industry represented in our event. Very good. So 2/3 seems like from the industry, and equal representation of the, changing a little bit, slightly more on the investor than the startup. Wonderful. All right. So that's it. And then for the answers to question 1, please scan the QR code and let us know which answer you found most interesting and resonating with your vision on the next 5 years. So I see coming up now, we've seen 5G enhancing device and cloud. And that is changing very quickly. Okay. So we start seeing smart unconnected devices coming up as well. So there's still about 30 seconds left. So if you haven't had a chance to scan, please scan and let us know what you think. So I saw every answer has a score. That's wonderful. Oh, now we see smart unconnected devices. That got the highest score, followed by 5G enhancing devices and cloud and distributed edge computing. All right, it's a race. The race is on. Okay, it's changing every second now. We are down the wire. 5 more seconds to go. Wonderful, wonderful. Distributed edge computing, 5G enhancing cloud, and smart unconnected device. Those got the highest score. So let's hold on to this and we will discuss that right after. But while the audience still have the phone, I want you to also go right ahead and answer question number 2 as well. Vote on question number 2. So if it's on your screen already, please give us your vote on question number 2 or scan the QR code to bring up and vote for the answers that you think resonate the most. That would be the most challenging, but will be super disruptive in 10 years. Smart dust. Okay, everybody wants to see smart dust, and I'm a big fan of Ant-Man movie, so this is quite exciting. Nomadic edge computing. Okay, 30 seconds to go. Brainwave interface now in the running. Okay. So every second counts. So if you haven't voted, please vote. True autonomy also getting high score on the second. 3, 2, 1. Okay. The voting is now closed and the results are in. So can we bring back the first poll, please? Perfect. So let's see here. So the audience has spoken that we think in the next 5 years, the most impactful is 5G. And then smart unconnected devices. Okay. And anything that jump out to you, the panelists, or anything surprising trends for this one? So maybe I'll pick on Dean.
I'm a little bit surprised of smart unconnected devices. I'm not exactly sure what that means. I guess what it means is the devices are maybe perhaps having, in-home connectivity or short air, personal area network connectivity. I just assume there has to be some connectivity involved in what makes that device smart. So I'm a little unsure that actually there's no connectivity involved at all.
So that's actually, I think that's a summary of my longer proposal. And, for example, for things like, I think there are a bunch of things that can be smart without any connectivity at all. That's kind of one of my starting points is, hey, if you've got something where, for example, with my light switch example, maybe you want connectivity, but maybe you can just do a lot without actually having your light switches connected.
So that's interesting, Pete, because one of the things in 5G is there are flavors of 5G that are sort of like, I call them back to the future. So they're actually stripped down. They don't have all the bells and whistles that the 1 gigabit connectivity version of 5G has. They might be for a device that turns on once a year or once every couple years and then goes back to sleep. So there's narrow band IoT. It uses just a sliver of spectrum and just has, supports like a 10-year battery life. And one of the things that I think that is an important trend in 5G. And I actually do see that as a trend in 6G for sure. Another example of that might be, we have this terrible problem, the digital divide, right? So the digital divide, although it's a technical regulatory problem, it's largely an economic problem. So how do we get devices that for kids, and it's an urban, rural, suburban problem, that are very low cost, but provide enough and therefore the price that an operator would sell them for the connectivity for it can be very cheap. But on the other hand, they provide enough, they're good enough for the uses that kids would have. And so that's something the government is sort of tried to focus on in the last year in 5G, that Congress funded something called the Emergency Connectivity Fund, or ECF. There have been 10 million devices provided to kids. There are 5 million kids who have broadband capability today that didn't have it before. But I see that as kind of maybe another example where maybe not just no connectivity, but I understand what you're talking about. But I do think that there will be flavors built within 6G just as there are within 5G.
I think adding to that, the idea of disconnected intelligence, I like that term, is an imperative. I mean, if we have an autonomous vehicle that's cruising down the road and suddenly loses its network connectivity entirely, it's got to be able to operate at some level without connectivity. And so it's an imperative. It's not a wish list item. Some use cases demand it. And then to Pete's point, there's certainly, especially as devices get smaller and smaller, there are some uses of edge computing that simply don't need connectivity at all, whether it be a motion sensor or whatever use case you might imagine. And that maybe this raises the issue or the topic of, in the future, when you buy a premium version of your product, you might be paying more for additional features like you do on a Tesla if you want to pay for the full autonomous driving feature, but you might also be paying more for richer connectivity. And richer connectivity might not simply be latency and bandwidth, but it might be a bunch of services that are integrated into that connectivity. And so we might begin to see connectivity in and of itself being offered as a product or a service that has different tiers of quality and value.
Maybe I could add to some of this. So we're seeing just now edge devices or edge compute type of devices where actually there's actually no battery needed at all, no power source. So one would ask, how does it work then? Harvesting energy from electromagnetic waves themselves or light or whatever, and using that to power very lightweight, thin type of computing. As you can imagine, these things can't get that much power. But essentially now, instead of saying the battery life is for a year or 6 months, it's like forever, basically. Some of these things don't even have a concept of a backup or any battery at all. I've seen like LED lights that could light up something. I've seen things where it actually could power a very, very lightweight, small processor, in fact. But then most of the time it'll stay for a little while and then go to sleep, and then use that to charge its own battery sometimes. But there's really no power source for it. So I could see things like NB-IoT types of devices where you're maybe at best sending a few kilobits per day even or so, and not beyond more than that. If you think about like really the 10-year horizon, if you're talking about stuff that's going to be hooked up to a human or something, you're not going to walk around with a power source to use. So these things would have to be something like that, right? The energy harvesting based on the environment rather than a physical power connectivity or a battery pack. There are some of these that are already popping up. I could see at very infancy right now, but I could imagine this happening in the next 10 years, and particularly at the enabling technology being 6G for something like this.
Very nice. So maybe we should bring up the second poll and then look at the results once again. All right, for this one, I need to make the screen a little bigger. So brainwave interface, that's the one that got the most. And then the one that got the least is autonomous defined edge. Okay. And then we have about the type of true economies, smart dust, and 5G. So anyone surprised about autonomous defined edge?
I'm not surprised, but I'm just bummed that Elon did not show up in that thing. But yeah, the brainwave thing, that's what I had put up and down. I think those are really interesting, like augmenting humans with machines. It sounds science fiction, but I think that's like the next big wave of things to happen. We do that medically today through non-intelligent augmentation, right? Whether it's knee replacement or something like that, but kind of going to the next level from there and sort of doing things in conjunction in terms of intelligent devices that are embedded with humans. It sounds a little out there, but I have seen a few startups that do things like this, particularly with optical processing, things like that. They're very nichey, pretty clunky. But I think in next 10 years, I could see that being the way. I certainly think that the brainwave type of things, these things take a while, not just from technology perspective, but from a regulation perspective too. But I do think that will happen within the next 10 years. Probably start very, very slow, but within 10 years, I think we're going to start seeing things like this.
What about you, Elena? Does that resonate with your investment trend and investment thesis?
Definitely along the longer run, yes, if we look at a 10 years trend, it's very much of a long-term patient investment. But the eye-opening part is the human-machine interactivity and how that move the whole edge into the next phase. Definitely excited about the opportunities.
And maybe I'd like to dig a little deeper, Pete, in terms of the software development for enabling, accelerating human brainwave interface. You see a lot of innovation that might make it possible in 10 years?
Honestly, I haven't looked that closely at the ML models and things that tend to get used for the brainwave interface stuff. So I would be just guessing if I had to talk about what we actually need to do on the software side. I'll leave that to somebody else who's got more of a background in that.
Anything you want to chime in on this, Mike?
No, I think Pete summarized very well for myself as well.
Very good, very good. So anyone else see any interesting trends that they agree or disagree with from the poll results?
I'll say something. It's not that I agree or disagree, but I would love to see a fully autonomous vehicle be introduced and be used. That's actually a true pain point for a lot of us. We're not supposed to be looking at our cell phone while we're driving, even with a Tesla autopilot, because you have to hold the steering, otherwise it will kick you out. But we do it anyway. So I'd say that's like one that I'd love to see happen sooner than later.
Great, wonderful. So now I think we are have about half an hour left. So I'm gonna open up the floor for the audience Q&A. So everyone, please feel free to post your question on the chat on your right-hand side, and we will try to get to as many questions as we can. And while we are waiting for the audience questions, I got to ask this as the investor in clean tech, right? When I read the news that was predicting that, I think by the end of this decade or so, we're gonna see that 8% of the electricity consumption being devoted to the cloud. And then now we start to see the computation from the cloud shifted to the edge network, edge device. Adding those layers, do you think it's actually help reducing the energy consumption, or it's just adding more computation, more energy consumption, but it's just harder to track now because you have so many layers that's doing computing? So maybe from the industry standpoint, do we really pay enough attention on the sustainability? Anyone want to chime in?
I do think sustainability is already emerging as a major focus in 6G, and it will have to be a major focus in the design of 6G to design wireless technology that's much more sustainable.
Very well. And do you see this as something that maybe the regulator should play a role in setting up the standard and requirement, or is this something that we will eventually gradually moving toward that direction, Dean?
Yeah, I don't think the regulators will have to set the standard, and I don't think it's really they're not really set up to set the standards. But I do think that regulators really paid no attention to the standard setting for, say, 3G, very little. In 4G, regulators started to take, some regulators started to observe standards setting in the development of 4G. In 5G, a lot of the world's regulators go to the standards group meetings and are involved as observers. And I think just the same way that various vertical industries like automotive and others are at the table, I think the government regulators will continue to be at the table observing and mostly getting ready so that, in the 3G days, once the standard was set, then the government would kind of wake up from a deep slumber and they would have to then start from scratch and doing all the things that they needed to do on their end to enable deployment. And that would consume a lot of time. I think we have shortcutted that process substantially in 5G. And I think, again, that's kind of state of the art, that the government allocation process can proceed in parallel with the finalization of the standard.
Very well. So let me try to see the question from the audience. So the first question that I saw from Spencer, 5G signals go about 1 kilometer, requires many nodes and tower with high population density. It's justified by consumer usage, but not in low population density area where industry tend to be. How can 5G be effectively implemented in more remote industrial areas?
Yeah, so that's a great question. There are a number of different aspects of 5G itself that we're seeing in the technology get played out to address this problem. And I need to clarify, 5G signals at a relatively lower spectrum band, so in the low or mid band range, can go a kilometer. 5G, when deployed in what we call millimeter wave, can only go about 500 meters. And so 5G millimeter, and we're talking for mobile. So for mobile connectivity, like at a stadium, inside a factory, at a warehouse, 5G millimeter wave is actually, very well suited within a venue like that to provide very, very good connectivity. The nice thing about, sorry to get a little geeky here, but 5G millimeter wave spectrum is very cheap because of the economics of it. And so within a factory, within an industrial setting, it can be deployed very economically. Now, when we're talking, though, about, say, rural connectivity to major, to a school, to a library, to a hospital, there's another technology, and this is, again, a little bit like Back to the Future. There's another technology within 5G that's very well suited for that, and that would be fixed wireless access, again, using 5G millimeter wave. So at a very low cost, because, again, the spectrum cost is very minimal, 5G can be provided on a fixed basis to a library, to a hospital, to a school, to population centers within rural areas. Just because an area has a low population density, it doesn't mean people are just always among themselves. There are places where people congregate, and it can also be provided on a fixed basis to someone's house. And we're talking about connectivity that you could only dream about on a wireline basis, providing like a gigabit connectivity to someone's house in a rural area using fixed wireless is tremendous. So I do think that 5G has these technical capabilities to do this. And, the challenge is to see, it get deployed on a wide scale. Verizon and T-Mobile are both leaders in starting to deploy this fixed wireless on a wide scale. We'll see how that's going to play out.
Yeah, if I could just add real quickly to that. So yeah, he's right. Millimeter wave is path loss is too high, so therefore it doesn't go too far, which means you need a lot of small cell or some devices to densely to do this in a dense manner, which is expensive. So it doesn't really fit well for something like a rural area where there are not that many subscribers because the ROI wouldn't be there. So mid-band spectrum, which is typically in the 3.5-ish type of world where you can get to like a kilometer, as the question said. But even then, it's for rural areas. Why would an operator care to do that if the density of population isn't there? So that's where the regulators or the policymakers come in. Is you have to make the spectrum cheaper. And there is something called CBRS that allows for that, where it is cheaper to own such spectrum. And that's probably the only real knobs we have to do such a thing, to incentivize operators to go deploy in areas where they're not, that ROI isn't high, but yet it's still expensive. So you have to bring that cost down. The industry in general, through economies of scale, will go down the cost of deployment, but some making this cheaper on the spectrum side. The other is regulations itself to make it expensive to deploy things, getting permits and things like that. And maybe loosening that a little bit might also help that cause.
So I could just add, and I agree with everything Vinay said, and thanks, Vinay. The other thing that makes spectrum absolutely the cheapest is unlicensed spectrum. So the spectrum that, for example, Wi-Fi and Bluetooth and other technologies that don't require an operator to buy the spectrum. The trade-off is it's a little bit like a public park or the beach. You don't get ownership the way you would but in private property, in a private property sense, but you get to use it subject to the rights of everyone else to use it. So until 4G, that was strictly the domain of technologies like Wi-Fi. In 4G, the cellular industry started to use unlicensed spectrum, and we saw an unlicensed flavor of 4G, two flavors actually, called LTU and LAA. In 5G, and those were kind of 4G, those were late in the game for 4G. For 5G, that technology, that flavor of 5G is being designed from the ground up. So a version of it that could operate in spectrum that that there is no cost to at all. And then the other last point is just, so there are public networks where you're trying to provide connectivity to all comers, but then, and I think the questioner is kind of getting at a different kind of model where you really want a private network. You're just trying to provide connectivity. The owner of the factory just wants to provide connectivity within its factory. CBRS, which Vinay mentioned, was the first instance where that could become actually in the United States, where we have kind of a regulatory model that embraces that, but then the technology had to come along. In 5G, there's really technology built in for this kind of private networking model, and we'll see how that's going to play out.
Yeah, I agree, Dean, and I think there's so much interest in CBRS, right? I mean, I think that we're going to know in just a few years, private networks, the amount of interest, the amount of innovation, the amount of it's going to be pretty interesting, because it looks like it's going to really make some transformation in access and the way that people thinks about managing assets. It also even potentially helps relative to that whole autonomy conversation, because it is looking like about potentially how you connect, factories and robots and all those kinds of things. There's a lot of attraction where, the quality of service, some of the attributes, as you mentioned, in 5G that maybe, Bluetooth or Wi-Fi or other kind of PON, personal area network type things, were just not robust enough. So I think that's a great, you watch that space and see what real deployment looks like, but the interest is off the charts right now.
I think this is a really good discussion. I think these things are really important. The features and capabilities and the stability of the network around us. In terms of edge computing, though, there's another depth of complexity here, in that I think edge computing in the future, does not assume a homogeneous network connectivity. It does not assume that all network connectivity is the same no matter where you are. you might be in a rural location in the future on your Chromebook and you want to do an autocomplete. You're doing a word processing and it wants to autocomplete, and it might have to go to its local database on its own disk or SSD to do that dictionary lookup and to do the autocomplete. But if you're in your home and you're next to your desktop, which is plugged into the wall, and you're on your Chromebook on a battery doing word processing and it wants to do an autocomplete, it might find it to be more power efficient, cost effective, and even lower latency to go get that data from a nearby device. And if you're in a very populated urban environment, a lot of things going on that Chromebook, as just this example, could be services that you're getting over the network and not having to be done on your Chromebook. And so using this as kind of a crude example, the edge device, the edge computing device in the future, has got to operate in a lot of different networking environments, including no network, and we talked about that earlier in this panel discussion, or in expensive network connectivity, or in easy or almost kind of quasi-free network connectivity. And the devices in the future are really going to have to be, I think, much more smart about where they do their computing, where they can do their computing to be most power efficient, cost effective, and all these things at the same time. And so I think it's more complex than just what's the homogeneous network experience across the board.
Very nice. So maybe let's move on to Ava's question. Metaverse seems to be the next big thing. Will edge computing play a big role in making it happen? And when will we see Metaverse take off? So maybe Elena, are you investing in Metaverse? Any prediction?
I'm happy to share a couple of examples. Interesting question, right? Metaverse, there's definitely the consumer element, but there's also the more enterprise needs as well. From if you think about a wind turbine in Metaverse training setting, we're talking about multi-million polygon of object. You're trying to bring that digital twin through Metaverse. So high expert, instead of traveling, you could stay on the edge and video conferencing through the Metaverse, really fixing up a really complex machine. So there's a different element to it. I think for edge compute, probably the second use case, B2B use case, is more relevant here in the Metaverse with edge computing related. In that case, Ava, definitely the edge compute will play a big role, especially in the complex geometrical computation use cases where so much due to the bandwidth and latency challenge with the panel spoke of earlier, right? A lot of things will be need to done in an on-premise space. It's always going to be a hybrid model. But what data you keep on the edge, what data are you going to transmit back to the cloud, and how do you make that intelligent decision? All that orchestration, virtualization from edge compute will marry to the layer Metaverse. So it's a very interesting trend and monitoring a number of innovations in this space.
Do you have sort of a prediction where we will start to see it taking off a big time, 5 years or 10 years horizon?
I definitely see there's low-hanging fruit, wave of adaptation cycle. Some of for instance, even during COVID, the pandemic is such a powerhouse in a semiconductor manufacturer house. During COVID, you can't travel someone from, let's say, California to Germany or anywhere, and you do need that capability right away. So I see that acceleration from the training and from the predictive maintenance perspective is happening already. And there's probably different wave of adaptation, and overall, eventually over 5 to 10 years, it will be more ubiquitous. But at this point, we're seeing the early penetrations.
Very well. And Vinay, do you have anything to chime in related to this?
Yeah, so I actually speak to those guys at Meta, kind of popularize the word metaverse. I think a lot of what metaverse is still to be defined. It's still an umbrella term for many things. AR, VR is always the thing that comes up with it. But to do that, you need headsets, you need technology that goes with those headsets to make that immersive. As probably everyone has noticed, AR, VR has been around us for a few years now, but hasn't really taken off. Just the fact that we're doing this over or Zoom or laptops and not with a headset kind of says that. So we're not quite there yet, both from a physics of point of view. There's few challenges in here that are technological that need to be solved, and then there's cost issues associated with it. But specifically looking at and speaking to these meta type of people who are plotting what the next 5 years might be, the challenges are, let's say that the headsets are cost effective and battery efficient, and we get the optics down and we are able to render properly. But you also have to have an operator that sees money in this, right? So if the money is going to ARPU, as they call it, is going to the cloud companies, what's in it for the operator to go and deploy these expensive networks? If it's a completely private network, okay, perhaps the operator doesn't care. But it's, for typically these things become big only when consumer adoption is there. And because that's where the scale is. So I can see maybe like smaller steps happening one at a time. First, just being an enterprise-driven type of applications, like people use words like digital twins and things like that, where you're talking to a colleague that's not in this room but somewhere else, but it's more immersive. You could see around you and around where that person is. Easier. So that's maybe an incremental thing. Gaming could be another where it could be self-contained as a problem. But for this to be really ubiquitous across every application, then and that's really the goal of Facebook or Meta, the company, to be able to have billions of people use it, not just millions of people use it. I think that has a whole ecosystem that has to fall in place. That's essentially going down the path of, I don't know, I don't want to call it replacing the cell phone, but kind of going that route, right? That becomes the communication apparatus, a headset rather than the phone. I think that has a long ways to go, but that definitely seems to be the trend. All major companies where I am in the Bay Area big companies are working on a headset. So I think it does make sense that that's where we're headed. But I don't believe it's going to be within the next 5 years.
Yeah, I think it's transformational. In fact, I think that Meta is in and of itself. What did B2B look like 150 years ago? A farmer would bring his wagon full of wheat and he would trade it with his neighbor for a carton full of milk, for example, and that was B2B. And then, of course, we saw the emergence of the mercantile exchange, where now you could bring your wheat in and have some broker kind of take it and pay you for it, and then that broker would figure out who to sell it to. And then we can look at the stock exchange, where a lot of this was electrified or electronified, and just the scale in commerce that was possible from thousands to millions, perhaps to billions of people who can do B2B transactions. And I think that the metaverse is truly transformational. It has promised to be transformational, where now this kind of a B2B construct can be person to person. It can be meeting in a virtual environment, and it can be handing over a Bitcoin or some kind of financial instrument for transacting business. And the scale, the planetary scale, the human scale that this can grow to is just unfathomable in fact. And so, I do think that metaverse will prove to be transformational. I do think that we have not yet identified all of these use cases that will be commonplace in 20 years from now, and I think some of those are yet to be envisioned.
Very nice. And I think there's also a related question from Lena. What is the killer applications beside metaverse for edge computing at this moment? Is it autonomous driving or is it something else? Any example?
I could kick in. I think computer vision is by far, I believe, one of the more dominant complex use cases of edge computing, especially involving AI and machine learning. I mentioned earlier, we can get 400 trillion operations per second into a very small package today. That little package can drive 20 high definition cameras running a dozen very complex neural networks in parallel on every frame of every high def video across 20 cameras, all within a matter of watts of power. The use cases for computer vision are being realized now because some of the software and the hardware capability has really come together just recently, and we're seeing that as a real push for machine learning at the edge today. Will computer vision be the dominant use case in 5, 10, 15, 20 years from now? Perhaps not, but absolutely it's on fire right now in terms of there's just a near infinite number of use cases that benefit from computer vision.
Very nice. There are also questions from Catherine about what does the edge computing adoption looks like outside of North America? Do you see certain part of the world leading adoption in the next 5 years, and why?
So maybe I'll just start that one off. I mean, I think this kind of riffs off of what Mike said, but I mean, I think video has always been kind of at the forefront, I think, relative to, if you want to look at some of these trends, right? And if you look at the first part of edge computing, I would argue, are CDNs, content delivery networks, which was basically putting content closer to users so that you could limit some of the latency and bandwidth impacts across the network. You now are seeing the same thing kind of on the ingest side, right? Which is kind of this computer vision, analytics around vision and doing inference on those things and just pushing up the information. I think a lot of countries are a little bit more advanced in using some of that video data. Of course, it's a highly discussed area because of confidentiality and what is that data being used. But if I use the retail example, I think we're all used to kind of walking into a retail store and seeing cameras, right? And those are security cameras typically. And, I think most of that data no one looks at that data until there's an event or there's theft or something like that. Well, there's a ton of significantly valuable data potentially to a retail operator in that. And again, how many people came in the store that day, how many men, how many women, how many people purchased, how long were they typically there? All that data exists there. And so to mine that data and to get that information and doing it so in a way that still protects confidentiality and is something that doesn't impose on privacy is something that needs to be closely managed. But I would say the U.S. is not leading in that area, and there's many other countries that are much more advanced in that area.
Very well. Maybe we have one more question that we can ask. What are some of the innovations that could enhance edge computing security? Any thought on that, Chris or Vinay?
Yeah, I mean, I don't want to dominate, but so confidential computing, right, is a hot topic if you kind of look at this. And the idea of confidential computing is, I mean, one of the things that we've moved to is shared computing. So as many of you know, when you go to cloud, oftentimes you're sharing a resource. So you're actually potentially having multiple customers, multiple jobs on the same processor. And so there's a lot of need to protect those things. And there's a lot of interest even for the cloud operator to not be able to see your workload. So if you look at something like confidential computing, the CCA, Confidential Computing Alliance, you can see technologies that are being developed to go do this. And we believe there's applicability in both the cloud for multi-premise, multi-tenant applications, but also at the edge and even endpoints.
Yeah,
Thank
maybe
you
I
so
could just
much.
add. I could just add to that. So, security is probably one of the biggest things that comes up when people talk about edge computing. Meaning, is it secure? How do I trust it? How do I know? Even with 5G, people ask those questions. Fundamentally, I think the technologies like cryptography itself is pretty good in all of these things. The applications or implementations of them and those practices is probably where the world has to improve quite a bit. The fundamental technologies I think are pretty good, but there is going to be, how do you create a safe network or a secure data center at the edge? Often the hacks or these things happen not because underlying technology is at fault. It's really, someone shared a password they shouldn't have, or someone created a backdoor that they shouldn't have, someone left something open. So those are the types of things that, that goes more into the deployments and the application practices. Uh, I certainly think that's one of the bigger concerns people have, and that need to be solved in a holistic manner somehow. I don't think the industry figured out yet how all these things can come together, but it is a problem statement for sure for this decade.
But thank you so much. We still have a lot more questions and we don't have time to go through. I just cannot believe how fast time flies. And this has been a wonderful session where we touch upon so many aspects of edge computing, from use cases to software and hardware enabling computing and connectivity on the edge. I think I can speak for many of us in the audience that we are now so much more optimistic and inspired about the possibilities of the future. And I want to extend one final and sincere thanks to our panelists for their valuable time, sharing their thought leadership and their passions with all of us. And to all of you who are watching, participating in the poll, and asking our great question during the event today, thank you so much. None of this would be possible without all of you. So thank you all the panelists. And although our session 3 today has come to a close, please don't forget to check out our remaining sessions in Industry 5.0 tomorrow and the Future of Mobility on Friday. So tomorrow with our Industry 5.0 panel, you will meet our world-class thought leaders from academia and industry and startups, sharing their insights on how to accelerate digital transformation while enabling cleaner and more sustainable industry. We touch upon the energy efficiency in edge computing today, and I personally cannot wait to learn how we might shape a more efficient and a more sustainable world in the future in tomorrow's sessions. And if you like our conversation today, please feel free to share and check us out on LinkedIn or WeChat by scanning these QR codes you see on the screen, and contribute to this engagement on digital transformation even after this event concludes. And if you like to share to your friends and neighbors about DX Week, please feel free to use the hashtag DX Week 2022 on LinkedIn. And thank you once again to our panelists, to our wonderful audience, and we hope to see you all again tomorrow. Bye now.